Hello everybody. Well, if you read the description of this video, or the title, then you probably already know what this box has in it, but there it is right there, straight from Australia, Super PID. So let's get started. I'm pretty excited about this actually, because I'm hoping it improves my machine a little bit. But anyways, let's see what we got. Oh wow. It's much smaller than I thought it would be. But yeah, there it is. You got the Super PID itself, and then some of the cabling and potentiometer. That's all set up. It's even got some standoffs for the board, so that's pretty cool. And then also in here I've got just a basic plastic housing for it. I kind of didn't know what I wanted to do, so I thought I'd buy that. I think it costed an extra $10, so that's really what I did there. So wow, yeah. So that's what it looks like in the package. Now let's get it out of here and let's look at it a little bit more closely. Alright, so we finally got it out of the packaging. There's not much to it, as you can see. We took the potentiometer and the optical sensor off of the terminal block down here. Got a little PIC microcontroller of some sort here underneath some sort of an epoxy with a logo on it. I'm guessing they're trying to hide what kind of a chip it is, but I don't know, that's kind of bull crap, but whatever. I got a little TRIAC, which is the chip that really makes everything work here. I got a couple opto isolators, I'm guessing, right there and there. Some fireproof resistors, diode, you know, got probably a pretty healthy sized fuse right in there, the bar fuse. It's going off the mains, I believe, from the looks of it. Yeah, that's what I'm guessing. So yeah, it's very, very simple. Not a lot to it. Alright, so as you can see right here, I've got my DW660 apart, and I'm basically in the process of setting up the sensor that's going to track the shaft for the RPM tracking on the Super PID. And basically they give you, in the package, they give you this little tube. You're supposed to drill a hole into the side of your router or whatever, and then run this, you know, on it, and be able to run the sensor into it through that. But basically I came into kind of a situation where I have this dust shoe that I love, and it kind of blocks the only area that the shaft is visible on right there. So what I ended up doing is I drilled a hole into the back, as you can see, of the dust shoe, and then a hole into the spot where it needs to be there, and it just kind of will be able to pop in, and I'll have it fastened somehow so it works pretty good. And then it'll basically just, if I can kind of go like that, and it should be able to track pretty good. So yeah, not a bad setup. I think it should work out real good and smooth, and should look neat and tidy, and shouldn't look like a Frankenstein of a machine, which is, you know, kind of one of the things that I'm worried about with my machine, doing all these mods with it, is that it ends up becoming this Frankenstein beast that looks horrific. You know, it may work good, but I want it to look nice too. So setting things up so they look clean and nice like this is, you know, kind of important to me, so I'm happy with that. As you can see, I've got the shaft of the spindle taped off halfways, which is basically so I can paint half of it white and half of it black. Kind of a neat thing about this is because it has this hexagon shape like bolting or nut like area for holding the spindle in place when you're changing on bits. It was really easy to find approximately the halfway point. Alright, so I got the Super PID set up in the test mode right now. So it's just powered up with 5V, and I've got my spindle with the shaft painted white and black, and I've got the sensor put on it, and so we can basically spin it and we can do a little bit of a test to make sure that we are actually doing pretty good on the pickup of the white and black paint. You can see right there as it's white, the bar is like full, and the second it goes to black, it's almost down to the bottom, which according to the instructions, that's what we want to see. So yeah, that's pretty neat. Alright, so as you can see right there, the sensor's mounted right there, and I still have to figure out how I'm going to route the wiring. I think what I'm going to do is zip tie it up kind of like that, and then run it back along with the power cable. Right now everything is really still up in the air on all that. Probably going to be something where I'm going to have to start thinking about getting a drag chain set up on the machine, simply because it is getting to be a lot of wires. So alright, so now the Super PID is all mounted up basically in its configuration. As you can see, I still don't have the front plate on it. That's because I haven't milled it yet. But you can see I've got the temperature probe connector down here, got the RPM sensor connector here, and then have both power and the on-off signal, or the on signal, and the PWM signal wires going to the PC from this connector. Have a switch basically right here that can switch between the PWM signal for speed control, or if I switch it to this, then all of a sudden the potentiometer right here, which doesn't have a knob yet, will control the speed control. Up top is a emergency shutoff switch basically that is wired through to the mains live wire, which basically means that it doesn't have power right now, but you basically just turn that on. And then over here we kind of have LinuxCNC, which basically just has a start-stop button, so we'll just turn this on. And as you can see right here, hopefully. Alright, so basically you can see we're at 5,000 RPM, and as we click on this little button, we're going to basically spin up, and you can see right there, the revolutions of the spindle speed is right there. So we'll move it up to 8,000, and then we'll go back over here, and as you can see we're at about 8,000 right now. So it's pretty cool. And then I can use I don't have to click on the button, also I can use the keyboard. So that's 15, should be. Yep, it's about 15. Go all the way up to 3,000, or 30,000. And there it is. So it just basically turns off, turns on, using the controls within LinuxCNC. The Super PID is all working pretty good right now. Still got some finalizing things to do. I think I'm going to actually run another cable for power and repurpose some of the pins that I was using for power on this connector. There's a telemetry out basically that allows me to give LinuxCNC the ability to actually see what the spindle speed is according to the Super PID. So that'll give a better closed loop kind of system, so that the actual control software, LinuxCNC, actually knows what's going on completely, and I'm not relying solely on the Super PID. Basically, that's how that works. So as you can see that, but what if we have a software that we don't want to mess around with speeds that are all set? We can switch into the potentiometer mode, and we can hit start from LinuxCNC, and we'll start, and then basically we can spin up using this potentiometer now. So that's basically how everything works. I'm really happy with the way it's set up and everything, and it seems to be great, so I'm really happy with it. So thanks for watching.